Okay, compound and absolute value inequalities. So a compound inequality are two inequalities that are joined by the words and or. We have an and statement that can also be considered the intersection of the two, which is uses this symbol here, which looks like an upside down U. The or statement can also be called the union, which uses this capital U. So along with those, when we are graphing those, if you are looking at an and statement, and I'm graphing that, you want everything that is in between the two there. And if you have an or statement, that's going to be the stuff that's on the outsides. So or is on the outside, and is on the inside. Interval notation is another thing that we're going to look at. When you have square brackets on your interval notation, that means that it includes the endpoints. When you have round brackets, that means it's not including the endpoints, and those could be mixed and matched as well. So we'll show you that as we go through and get these answers. So our first example, we're going to solve and graph. So when you see this, and you have your variable in the middle like that, this is going to be an and statement. When it's an or statement, like you see here, it has the word or in it. So here, I'm going to treat this like I have two equal signs in there. So instead of doing everything to both sides of the equation, we're actually going to do it to all three parts of this equation. So if I'm going to get the y by itself, the first thing I have to do is add 2, and it has to go to all three parts on here. Now I would divide both sides by 3, not both, but all sides. Okay, so this would be the inequality that goes with that. That's the compound inequality, the solution that I'm looking for. So another way that we could write that, this would be using the set builder notation that was on the notes yesterday. This is saying all values of y such that 4 is less than or equal to y, which is less than 7. So that's saying that y is between 4 and 7, including the 4. Now, interval notation, the way we could write that would be, since it's including the 4, I would put a square bracket there, and then I would put a round bracket on the 7, since the 7 is not included. And when I say included, I mean this has the equal sign underneath of it, this one does not. So if I'm going to graph it, I could say here's 4, 5, 6, 7, you can number them wherever you want. I'm going to go on 4. And that circle is going to be colored in because that 4 is included in my solution. And then the 7 is not included, so that gets an open circle. And since this is an and statement, it's everything in between. It's going to look like this. Okay? Alright, for example B, we have an or statement now, so you know what the graph is going to look like from above. And we're going to treat these both like two separate equations. So over here I would subtract 3 from both sides. And here, this is like multiplying by a -1. So I'm going to divide both sides by a -1. And remember, when you divide or multiply by a negative while solving an inequality, the sign has to flip directions. So now, if I would put this in the set builder notation, I could say x such that x is less than -1, or, so I'm using that union symbol, x is greater than or equal to -4. Okay, so if we're going to graph this, I'm going to label these -1, 0, 1, 2, 3, 4. So I have a dot on -1, and it's not filled in because that does not have the equal sign underneath, which means that -1 is not included in my answer. And over here, this should be a +4, sorry. Get rid of those negative signs on there, my bad. +4 is going to be a filled in circle, because that is included. And then our or statement, so like x is greater than or equal to 4, greater than means larger numbers, we're going this way. Less than goes this way. And there you have it. Example 2, now we are looking at absolute value on here. So this first one, they're trying to goof you up, they wrote it backwards. So whenever you see an inequality that's backwards like this, I want you to flip the whole thing around. So we're actually going to say the absolute value of D is less than 2. So I took the whole thing and flipped the whole thing around. So now these are going to be very similar to the problems that we did when we were solving absolute value equations. When I have a less than, let's make a little code over here actually. Less than, or if you have less than or equal to, these are going to be and statements. If you have greater than or equal to, those are going to be or statements. So using this, I know that it is less than, so this is going to be an and statement. So I'm going to say D could be less than 2 and D can be greater than -2. So remember when we did them with absolute value equations, we split them into the 2 and switch the sign. So you not only switch the sign, but you also switch the way that the inequality is facing. So now if I graph both of these, I have -2 and 2. And they both will have open circles on them, and it's an and statement in the middle, so we're shading in the middle here. So this is saying D is less than 2, so less than 2 is that way, and D is greater than -2, so that would be that way. So if I graph both these separately, sometimes this helps to see it, I would have one going like that, and I would have another one going like that. So where they intersect each other, that's the spot that we graphed, where they overlap there. Okay, so for part B, we're going to do the same type of thing. So this right away, I'm going to look at that and say it's greater than, so that's going to be or. Now I'm going to split it apart, so I have 2x minus 2 is greater than or equal to 4, or 2x minus 2 is less than or equal to -4. So you switch the sign and you switch the inequality. So I'm going to solve both of these now. So add 2, divide by 2, same thing here. So now I have x is greater than or equal to 3, or x is less than or equal to -1. So if I label these, -1 is going to be here, gets a filled in circle, and shaded below because we're going to less than numbers. 3 is here, also has a filled in circle, greater than numbers this way. Alright, so you have the last two to do on your own there. And of course, the joke of the day, why are fish so good at watching their weight? It's because they have a lot of scales. Alright, well I hope you have a wonderful day and make sure that you are kind to someone today.